So today we're going to learn about the quadratic formula and how we can use it to solve. So today's essential question is, I can use the quadratic formula to solve. That's today's essential question, so that's what we're going to do. Now, this right here, this 2x squared plus 3x minus 20, we can actually factor it, separate and solve it, or what I like to teach is tic-tac-toe. However, we want to get a good practice because when we get to using the quadratic formula, we're going to use it on some pretty difficult things. And so we're going to use this formula here, so negative b over 2a plus or minus the square root of b squared minus 4ac. And a, b, and c are right there. And we're just going to plug it into our formula. So to help us understand this, a is going to equal 2, b is going to equal 3, and c is going to equal negative 20. And so what I'm going to do is I'm going to take my numbers and put them into this formula. So negative b, or the opposite of b, so I have positive 3, so I'm going to use negative 3, plus or minus the square root of b squared, which is 3, minus 4 times a, which is 2, times c, which is negative 20, all over 2 times a, so that's 2 times 2. And when we compute all this, this is going to give us an x value, two of them actually, one for the positive and one for the negative sign on the top of that fraction, and we'll have our answer. So that's our first step. Then we're going to square the 3 and multiply 4 times 2 times 20 here. So we're going to keep the negative 3 and the plus or minus. 3 squared is 9. This is an x equals. And then 4 times 2 is 8 times 20 is 60. So we have a minus, and it'll be negative 160 all over 2 times 2 is 4. And then from here, we can put these terms in the middle. So we're going to get x is equal to negative 3 plus or minus the square root of 169 over 4. Let's go up here. Now we're ready to square root. So we have negative 3 plus or minus 13 over 4. And then we can break this part into two. So negative 3 plus 13 over 4, which is, and then negative 3 minus 13 over 4. So this would be 10 over 4, which is 5 over 2. And that's an x equals. And then we get negative 16 over 4, which is equal to negative 4. And that is also an x equals. And those are the answers, the zeros or the x-intercepts or the roots. That's what we found. So this is very similar to what we've been doing the whole time, where we factor, separate, and solve, or we complete the square. It's just another way of doing it that guarantees success. All right, so our next question is this one. Notice this doesn't equal 0, so I need to move this over here. So I'm going to add 10 to both sides. So I'm going to get 2m squared minus 7m minus 3 equals 0. And then we're going to use our formula. So if you don't remember the formula, I'm going to write it out over here in red. So negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the formula we're using. And so b is negative 7. So this is b, this is a, and this is c. So b is negative 7. I have negative 7, negative b, so this is positive 7 in the beginning. B squared is negative 7 squared minus 4 times a times c all over 2 times a. It's another 2. Again, I'm going to square the 7 and multiply everything, so we're going to, this is x equals, and we'll write it down at the end. So we have 7 plus or minus the square root of 49. And then minus, and then 4 times 2 times negative 3. So 4 times 2 is 8, times negative 3 is 24, So we have negative 24 all over 2 times 2 is 4. So basically we just multiply everything. And then we're going to take this, we're going to put it up here. So we have 7 plus or minus. And then if you need a calculator, you can get it out, or you can just do it in your head. So 49 and 24 make 73 over 4 square root. Now the square root of 73 cannot be reduced. So if it could, we could go ahead and reduce this now. But it can't. So this is kind of just where we're stuck. So 49 plus 24 is 73. That is correct. Okay, so that means x is going to equal this. We're not going to take it to any decimals or anything. This is what x is going to equal. Now if that 73 could be reduced, like let's say it was a root 80, then we'd have to break this down into root 16 and 5 and get 4 root 5. Okay, that has nothing to do with the problem. I'm just saying that we do always have to check that. Okay, so here we need an equals 0, so I'm going to add 5 to both sides. So you have 8a squared plus 6a plus 5 is equal to 0. And then on this one, we are ready. We have the a, we have the b, we have the c, and I'm going to use my quadratic formula again. That's up here, right there. So we have the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And we're going to multiply everything. So I'm going to do that now. So we got negative 6 plus or minus the square root of 36, and then 4 times 8. So 4 times 8 times 5 is 160, so we have minus 160 all over 16. Bring this up here. So we have negative 6 plus or minus the square root of 36 minus 160 is negative 124 all over 16. And we're going to have to reduce this negative 124. So however we want to do it, we can get read out and write negative root 124. We got to reduce this to two things so we can square root them. So this is going to be I root 4 times root 31. So then that's going to give us 2i. So when I simplify this, I'm going to get negative 6 plus or minus 2i root 31 over 16. And then we want to look at our numbers here. All these numbers in front, can we divide these by a number? The answer is yes. We can divide everything by 2. So we're going to divide everything by 2 to kind of reduce it. Just like if I had 4 over 8 and divided it by 2 to get 2 over 4, I'm doing the same thing here. So I'm going to divide everything by 2 to get a reduced fraction. So I'm going to get negative 3 plus or minus I root 31 over 8. And that's going to be our x value there. Okay? Sweet. All right, so this next word problem here, I'm just going to kind of look at it here. So we have a word problem here. We're going to use a quadratic formula on it. And I'm going to get this all within a space that you can read. So I'm just going to adjust this just a little bit so that we can read it, and then now we're going to solve it. Okay, an object launched directly upward at 65 feet per second from a platform 80 feet high. What will be the object's maximum height? When will it attain this height? Okay, so what we have to know here is that when we throw an object here, it follows this formula. So it's something that maybe you don't know, but it's negative 16t squared plus whatever our speed vertical is, so it's 64t, plus 80 is our current height. And what they want us to know is what will the object's maximum height and when we'll attain this height. I actually don't want to do that. I want to find out when it hits the ground instead. So let's change this problem here. So let me go ahead and pause my video. Alright, so notice I changed the question a little bit here. It's the same deal. We have the function written right there with the 64 and the 64 and then the 80. So this is the formula. So whenever you throw something in real life, this will actually model our height for us. And we want to know when it hits the ground. And so what we want to understand is when we hit the ground, what is our height? Well, it's 0. So this would be 0 is equal to negative 16t squared plus 64t plus 80. And then, so if we went on, 80 feet high, I don't know, our school's a little big for 80 feet high. So maybe we went to downtown Boise and went on one of those bigger buildings and threw something off straight up in the air. When is it going to hit the ground on the street, right? That's what they're asking. So like if you could just imagine we have an 80-foot building here, and then here's Mr. Hill, and I'm throwing something up and it's going to come down. Okay, and we want to know the time it takes for it to come down. And so this is our formula, and when we hit the ground it's 0. And we're going to use the quadratic formula to solve this. So negative b over 2a plus or minus b squared minus 4ac, the same stuff we've been using the whole time. But now we're going to have a little bigger numbers, and it's kind of a real life scenario here. So negative b is negative 64 plus or minus the square root of b squared, so 64 squared, minus 4 times a times c. What I'm going to do is I'm actually going to take this to a decimal. And that's 2 times a, so negative 16. Because I want to know the time, and fraction time doesn't really help us very much. So I'm going to multiply everything, just like I've done before in all my examples. So 64 times 64 is 4,096. We're going to minus 4 times 16 times 80, which is 5,120 over negative 32. Then we're going to subtract these, so, well, wait, I made a mistake. This number right here, let's squeeze this in here. So it's minus, and this is a negative right there. So notice I have two negatives in a row, so I'm not going to subtract them, I'm going to add them. So 5,120. So I get negative 664 plus or minus the square root of 10,240 over negative 32. So we're going to bring this up here. Square root of this, I'm going to actually take this to a decimal, is going to be 101.19. So we have negative 64 plus 101.19 over negative 32. That's going to give us an answer, and then we also have negative 64 minus 101.19 over negative 32. That's give us the second answer. So we're going to do both answers. So we're going to minus 64 from 101 there, and then divide it by negative 32. So it says it'll hit the ground in negative 1.16 seconds. Okay, that doesn't make any sense. So let's try the other one. So we have negative 64 minus 101.19, and then divided by negative 32. And we're going to get 5.16 seconds. And that sounds a lot better. Sounds a lot better. Okay, so notice that this is a negative number here, and that doesn't really exist, and so we're going to cross this out. So even though our math works, we can't have negative numbers in real life. So if we're on top of this building and I threw it at that speed, we're going to have to wait 5 seconds until it hits the car beneath us. So